Hello and welcome back to the lecture on applied econometrics. We have been talking about autocorrelation, and in the previous couple of lectures we actually were dealing with data, and we have shown how to conduct a Darwin-Watson test using data that might have autocorrelation present. Now in this lecture we are actually going to talk about Brieusch-Godfrey test, and using the same data set we are going to perform the Brieusch-Godfrey test using both R and Stata. So let's first talk about the test statistic that we use in case of Brieusch-Godfrey test. And we actually compute a chi-square value, and the chi-square value is approximately equal to, so chi-square calculated, we get this chi-square calculated, and that is approximately equal to n minus p into r square, and this n is the total number of observation. P is the number of, basically the order of the autoregressive model, basically autoregressive model that the error term follows. R square is the R square value that you get from the auxiliary regression, basically when you run when you have ut hat as your dependent variable. Okay, so this is your chi-square calculated, and if your chi-square calculated is less than chi-square for degrees of freedom p, actual chi-square value that you get from the table, then you say that you actually do not reject the null hypothesis, because the p value that you get is going to be, and p value that you get basically is going to be higher than your alpha level of significance, right? Alpha level of significance. So essentially you say that your null hypothesis here is that null hypothesis is rho is equal to 0, right? So all the rows, or if you have multiple rows, of course you can write row 1, row 2, and n number of rows, they are going to be is equal to 0, whereas alternative hypothesis rho I, any of these rho I is not equal to 0. So that is your alternative hypothesis. Now if I have this above, so I say you do not reject the null hypothesis, whereas if I have the following chi-square calculated is bigger than chi-square at p degrees of freedom, I would say that my null hypothesis, I reject the null hypothesis, but the p value is going to be less than the alpha level of significance, and you basically reject the null. Okay. So with this we will actually we'll sort of do the Brieusch-Godfrey test both using Stata as well as using R. So let's start with the Stata first, and the command, like previously what you've seen for DW's test, is pretty simple. All you have to do is you have to write after the model B Godfrey. Okay, so BGODFREY. So that's all you have to write, and if you write it, you will get the chi-square value 8.036 for degrees of freedom 1. So degrees of freedom here is essentially basically the order of your AR model, and the p value is pretty low. So essentially it shows that your model has autocorrelation. Okay. Similarly, if we use R, it's just like DW test. All you have to write here is BG test. Okay, BG test, and you can write the model. Okay, and if I write it, I will get a value. The Lagrange multiplier value LM is 8.036, exactly what you have found in using Stata, and you have degrees of freedom 1, and p value is pretty small. So essentially you say there is autocorrelation present. Now in R you can actually also define the order of your autocorrelation. So if it is AR1 model, AR2 model, or whatever model you want to see, let's say I write order is equal to 2 instead of 1. So the previous model was actually 1. Right. The previous model is actually 1. If I don't write anything, it will assume order is equal to 1. So, the result that you get is what you got in the first case. But if we have order equal to 2, of course, the values will change, but it still says that the autocorrelation is significant. So, you can actually test with different order. You can assume different order and you can sort of input those order, you can see what the results are. So, essentially we have seen in using both Bridge-Godfrey test as well as in Darby-Nordson statistic test that the data set we started with that has autocorrelation present. Now, what to do with that? So, given that we have autocorrelation, how can I actually resolve autocorrelation is the question. Now, in the next lecture, we are actually going to talk about how we can resolve autocorrelation if we have one. So, with this we will end the lecture here. Thank you.